Today we want to talk about how to graph parabolas. If you watched the first video, then you know the formulas used in writing different types of parabolas. One of the first things you want to identify is whether your parabola opens up, down, left, or right. And there's two things that we're going to notice so we can determine that. The first thing you notice is which variable is in the squared term, right? So this is the squared term. We have a y in the squared term, which means I'm going to be opening the graph either to the right or to the left. And so that is the first step. The second step is determine whether p is positive or negative. The way you determine that is do you see a negative sign outside of either one of these situations? And this obviously x is positive here and y is positive there. So there's no negative signs anywhere so that we know this is p is going to be a positive value. Remember that p is positive, it's going to be opening to the right. If p happened to be negative, it opened to the left. If you had a vertical axis of symmetry, then p positive would be up, p negative would be down. In this case, we have a horizontal axis of symmetry because the y part is squared, so we're going to be opening to the left or to the right. In order to graph this, we need a number of things. Number one, we want to figure out what the vertex is. Okay, vertex is always hk. For this example, our equation would have a generic form of x minus h equals, this is a 4p here, 4p times x minus h, and you have y minus k all squared. So that's our generic version of our formula. The 4p always goes with a non-squared side. What we can see here is h. Now notice the differences. In the original equation you have negative signs, and so here I'm going to have h is negative 1 and k is going to be positive 2. So the vertex we have is going to be a negative 1, positive 2. The next thing we want to identify is what p is. All right? So to find p, this part's somewhat confusing. P should be out in front of, well actually it's 4p, should be out in front of the non-squared term. And we see that here. I don't have a number written. There's always an implied 1 in that place, right? So the way that you solve for p is you're going to take 4p is equal to whatever number is out front, right? In this case it's a 1. So we solve for that, and we're going to find out that p would be equal to 1/4. Technically, this is all I need in order to graph something. And so what I'm going to do is I'm going to draw the parabola with this information. So the first thing we're going to do is we're going to label the vertex on our graph. So we're going to go over negative 1 and up to positive 2, right? So you're going to see that. Let me zoom in a little bit. And then what we're going to do from there is we are going to draw the rest. We know that p is 1/4. Now, honestly, that's a pretty small value. And so what I'm going to do is I'm just going to kind of estimate where the focus would be. Let me put that in a different color. So the focus is going to be 1/4 to the right. Why to the right? Well, it's because the parabola is going to be opening this direction, right? We know that the parabola opens to the right because p is positive and it's y squared. So the the focus goes inside the parabola. It's going to be going to the right side of the vertex. The directrix, which goes to the opposite side in the same distance, 1/4 back this way. All right, now obviously I'm just estimating these values. Okay, I'm not looking for super accurate results, especially when you have p's that are really, really small. What you're going to do is you're going to write down that information. So, and this is it. In terms of graphing it, you've got it done. Here, we're going to go forward 1/4, and we're going to go backwards 1/4. We're going to put the the focus inside the parabola, and the directrix just on the opposite side of my picture. And so here, I'm going to take that information, and we need to label the other parts. So we need to know what is my focus and my directrix, and we want to know the axis of symmetry. So there's essentially 4 elements plus the value for p that we want to figure out. The focus is going to be inside the parabola. We're always going to be kind of basing our choices for the focus and the directrix on the vertex. Essentially, if I were to take the vertex and move right one value, you can see there that I already know that the y-coordinate of the focus is going to be +2 because it's on the same line as the vertex, right? So even if I'm not quite sure the rest of it, that's obvious, okay? If I had been going up and down, it would have the same x value. In this case, we know that p is 1/4, so if I'm at -1, all right, so if we're at -1 and we go to the right 1/4, then my new x-coordinate is going to be -3/4 or -0.75. So we would say -3/4. Right? We were here at -1, and I moved this direction just 1/4. So when you go to the right, you're adding, so it'd be -1 plus 3/4. So technically, if you want a little formula for that, it's going to be h plus p to give you the x-coordinate of your vertex, or sorry, focus. The other part of that is just going to be k, because that was the original value. The directrix is just the other way around. I'm going backwards, so I'm going to the left. If I work the directrix backwards, I'm going to be going h minus p. In that case, you would end up going -1 minus 1/4, which is going to give me -5/4, or you could say -1.25. I'm okay with decimals here. But let me make a point here. This is not a coordinate. This is a line. A line always takes an equation. Every single vertical line ever written has a very similar equation. It's always x equals some number. Well, we know that number is -5/4. I will consistently write in fractions. So if I think that is a better way to do it. If the decimals are nice, I'm not going to mark off for those, but if the decimals are repeating and never ending, then you need to go with the fraction. The last element we're going to write out is what the axis of symmetry is, right? Well, that's actually quite easy. The axis of symmetry is the line that splits that into two equal pieces. If we were to draw that in, your axis of symmetry would look like this. It goes right through the vertex and the focus, and they share the same y-coordinate. So when I'm looking at this, the axis of symmetry is going to be y equals 2. I'll tell you this, the axis of symmetry will always take either x equals the x-coordinate of the vertex, if it's a vertical line, and it's always y equals the y-coordinate of the vertex if it is a horizontal line, right? It's going to go through this one, or if this had been vertical, it'd go through the x-coordinate. So this is directly linked to the vertex. One of these two values should always occur in the axis of symmetry. Okay, and so that brings us to the end, and what we noticed is that we had 1, 2, 3, 4 pieces to our parabola plus the graph. Sometimes I'm going to ask you just for the graph, sometimes I'll ask you for the pieces or some of the pieces, but this is a common task. Really, this is one version of this. The other way around is when I give it to you backwards. I'll give you some pieces, and I'm going to ask you to write out the equations. But for today, I want you to focus on just learning to graph the parabola and find the pieces of those parabolas. If you have any questions, let me know. The assignment is just to do the first 3 equations, or well, I've already done the first one, so the other 3 graphing problems on the parabola practice. So take some time, go through that, and we will go over those questions tomorrow. Have a great day.